Hi, welcome back to Mechanics and Control of Robotic Manipulator. We have already seen so far is actually we have started from what is position vector, rotation matrix, then we have come back to what you call compound rotations. In that a few different methods we have seen, finally we ended with what we call DH parameter. So this is what we have seen so far, and this particular lecture we are going to talk about more about DH representation. What that mean? So we would be actually like representing you can say one body to another body or one frame to another frame, how we can actually like transfer. So what sequence and what would be the final outcome. So in the sense we are actually like representing the frame I minus 1 to I, or we are trying to get the transfer, or you can say the transformation information of I with respect to I minus 1. This is what we are trying to find. So if that is the case, so what we can actually like expect from this lecture. So we would be talking about DH representation. Finally the outcome what you call the transformation matrix, but this is related to you call robotic arm, so people call arm matrix. And even this arm matrix we can obtain two way. So one we call actually like the standard representation. So that is actually like all the variable will be in the ith entity, where the other one is what you call non-standard, where it would be mixed of I and I minus 1. But in this particular course we would be keeping as non-standard. So obviously you should know what is standard and non-standard. So that we will actually like come back at the end. So we will start with the DH representation. So for that we would be taking a random body, in the sense random I minus 1 body, or a random link I minus 1 out of actually like a set of bodies. So that is what we are actually like trying to take. So you can see right now this is the general arrangement. We are trying to take the link I minus 1, which is actually like connected link I and link I minus 2. So obviously you know, like as per the Danawit-Artenberg representation, what it says. So any link is actually like a binary link, okay, and each binary link would be the name itself binary link. So it would be having two joints, and as per our case or as per the Danawit-Artenberg approach, so each joint would be having 1 DU of system or 1 DU of joints. So in that sense what we can see, the link I minus 1 to link I minus 1 is connected with the link I minus joint I minus 1, and the link I and I minus 1 is connected at the joint I, right. So this is what we are actually like trying to see. So now what we are actually like trying to say, like if we pick this link, okay, so if we actually like pick this link, so what that would be consist, that would be consist I minus 1 axis and ith axis. Can we actually like get the relative information of I frame? So we assume that the ith frame somewhere here and I minus 1 frame somewhere here. Can I actually like get ith frame information with respect to I minus 1? Can I get this or not? Okay. So that is what we are actually like interested. So this information can we get? So for that, first what we need to, we ask this, okay. We don't want I minus 1 which is connected to I minus 2 link, so that we are actually like cutting out. So now what we are taking? We are taking a link I minus 1 and link I specific. We want to see what is Zi minus 1 and Zi axis, because you know all the joint we fix it with respect to the Z axis or Z axis. So in the sense Zi minus 1 and Zi already we fixed. Now what we know, we don't know like how the Xi goes, because Xi is supposed to get the information from Zi and Zi plus 1. So right now we assume that the Xi goes this way, okay. So now we assume that this is the I minus 1 frame point and this is ith frame point. So I want actually like travel, or in the other way around, I want to know the information of I with respect to I minus 1. In the sense we have done like this, right. So the rotation matrix of B with respect to A and the position vector of B with respect to A we have done. Now we are actually like combining this and giving as a transformation matrix of B with respect to A. Now what is we are intended? We are intended that, so the transformation matrix of I with respect to I minus 1, okay. This is what we are interested. So for that what one can do? So there are two ways we can do. So one simple idea what we can see, for example something happened on the highway. So the highway is actually like probably little far from the current place. So you want to know the information what happened at the highway. Probably people say that there is a new board, sign board that's put, in that there is a spelling mistake, okay. somebody says something, it is A is missing, someone else says that no, A is added, somebody says that no, it is E added something. Okay. So these all actually like what the information you received from someone else. So instead of that, what you can do, you can actually travel to the highway and see what is the you can say the direction board and see what really the error. So the similar sense what we are trying to do, so instead of getting the information of I, okay, whatever the associated information of I frame, we don't want to get it from some other source, we travel to there. So if we are doing the travel, we have to make several subset. What that? So your Zi minus 1 and Zi is not parallel. Similarly, you don't know what is Xi minus 1, your Xi minus 1 and Xi are not parallel, and your I minus 1 to I, there is at least two distance we can see, right, one distance along this and another distance along this axis. In the sense, we want to try how to get this particular information. So for that, what we are trying to do first, so we are trying to make Zi minus 1 and Zi parallel, but what we wanted the information of I with respect to I minus 1. So what we can actually like try to do, you can draw the parallel line which is parallel to you call Zi, and then you can actually draw the common normal between these two lines, and this what we can say, this common normal would be the line of Xi minus 1. Okay. So now that is what we are trying to do. So you can see that we have fixed the Xi minus 1, which is actually like along the common normal, that too like the direction of Xi minus 1, we take it as a progressing side. So the progressing direction what we call the positive direction of Xi minus 1. Okay. So this Xi minus 1 is actually like come from where? The common, so common normal. So here what is the common normal? The common normal is actually like this is Zi minus Zi, this is Zi minus 1, you draw the common normal. Okay. So this is what the line of Xi minus 1, this is we have done now. So what else we can do? We can make it actually like a parallel, because we are interested to I. So we can actually like draw the parallel line, okay, to Zi with respect to the frame I minus 1. So this is the parallel line. So now what we are actually like taking it, so we are actually like from here we are actually like taking it 1, we make it parallel. So in order to make it Zi minus 1 and Zi parallel, so how much angle you have to rotate with respect to Xi minus 1? So that is what we already seen as alpha I minus 1. So this is what we did. Okay. So now what you can see, like you have something called Zi parallel and Zi minus 1. Now by rotating alpha angle with respect to Xi minus 1, it become, you can say, another axis called Zp. Now since it is actually like Zp has come, so I am keeping that as a new coordinate. So now because of that, we are actually like keeping it Xp parallel to the Xi minus 1. So now what you have done, one transformation you have done from Zi minus 1 to Zp with respect to Xi minus 1 done. So what that? So you have rotated about Xi minus 1, what angle? Alpha I minus 1. So what you did? So you made it Zi minus 1 parallel to Zi. So this is the first operation. So that is what we have written as a transformation 1. Rotate I minus 1 frame, okay, about I minus 1 Xi minus 1 axis with an angle of alpha I minus 1, which makes Zi minus 1 coincide with Zp. Okay. So now this is actually like clear, the first operation, which is actually like rotation matrix. So I will write this rotation matrix here, what we have done. So it is actually like rotated about x. So then you can write, so this is actually like alpha I minus 1 and this is minus sine alpha I minus 1. Okay. So then this is sine alpha I minus 1 and this is cos alpha I minus 1. Okay. This is the rotation matrix. If you want to write it in a transformation base, so Rx, and there is no positional change, in the sense you can write 0 0 0 and this is actually like 1 and this is 0 0 0. So this is what you did the first one, transformation, so which is actually like rotation. So that is what we did, first operation. So let us move to the second one. The second one is what we can do. So now you can see the P and I are distance apart. So I am actually like taking this extension xp and hit where this, in the sense, so you have actually like this road. So this is your highway, okay. This is your highway, which is actually like very good road, and this is a normal street road or probably state highway. So when you hit, so you are actually like done to reach, right. Probably every other aspect would be available, but probably the village road may not be available, you feel. So similar way, so what we have done, we have actually like make it parallel, and then we are trying to reach, in the sense you are somewhere here, you come back here, and now you are traveling and hitting the road. The same way, you have made a common normal, but if I travel along the common normal, what I will end up? I will end up with the zi axis. When I hit that point, I am keeping as q. So now what I keep, there is a zq which is parallel to zi, and zp and zq are parallel, but what difference between q and p? So there is a distance, right. That distance where you can realize with xp, right. So xp to what you call q, or you can say p to q along xp, the distance made, right. What that distance here we marked, which is nothing but ai minus 1. So in the sense what we did here, we have translated the point p in such a way that meet the point q. So now the second transformation has done. The second transformation is simple, you can say vector. So what vector? You have actually like translated along xi minus 1. So these are the position vector change. The remaining one is actually like identity matrix, right. So then you can see this is what the second operation, this is I minus 1. So a I minus 1, okay. So that is what this term. So now what we did the second transformation. So we will go the second transformation, what it says. So translate p along xp axis by a distance of ai minus 1, which makes zp coincide with zq, right. So now coming to the third operation, what one can expect, the xq and xi are angle apart. So what I can do, I can make a parallel line with xi. So this I can label it as xr. So now I can actually like label it as zr. So that is what we are going to do in the next picture. You can see that I mark it, so xi parallel at a point q, which I am denoting as xr. So now xq and xr are angle apart. How much angle? Theta angle with respect to what? The zr. So now what we can do? So zq and z are parallel although, but xq and xr are actually like non-parallel. So you make it parallel. So in the sense what you did, the rotation about z, how much angle? Theta I. So what you did, you made it, so xq parallel to xr. So this is what the operation. So what would be the rotation matrix in this case? So cos theta I minus sin theta I 0, sin theta I and cos theta I and 0, 0, 0, 1. So this is the rotation matrix, and you can actually like put it in a transformation way. So then this would be rz and 0, 0, 0, this is 0, 0, 0, 1. This is what you can write it. So now this is actually like 3 cross 3, and this is all will give 4 cross 4. What exactly we did the transformation, the third transformation, where we rotate the q axis or q coordinate. The coordinate we rotated about zr by an angle of theta I, so that we can make it xq coincide with xr. So this is the third operation, right. So now we will go to the next one. So what the next one? So you can see like now the I and r only distance apart. How much distance? It is along zi. How much distance? It is di distance, right. So now what you can see, the translation we have done, in the sense we travel from r to I along zi. So in the sense what you can see, this is identity matrix, because there is no rotation and all, because xr and xi parallel, zi and zr parallel, in the sense these are actually like identity. So in addition what we did, so this di in z axis rotated, sorry, translated. So now this is what the final transformation matrix. So what we did the transformation, so translate r coordinate along zi axis by a distance of di, which makes xr coincide with xi, or you can say the q coincide with I. So now what we did, we started with I minus 1 via p, q, r and reached I. So this is the way, but what we did every instant, with respect to moving frame we rotated, moving frame we translated. In the sense what we have 4 transformation matrix. So one is actually like, you can say rotation, I will write it in the other way around. So I will write first, so first thing is actually like the rotation. So rotation actually like I write this, so rotation about xi minus 1, which is alpha I minus 1. Then what we did, the translation we did along xi minus 1, which is actually like ai minus 1 distance. The third thing what we did, the rotation about z, so theta I, right. Then finally we translated along zi, so di distance, right. These are the 4 operation. But this is the first operation, this is the second operation, this is the third operation and this is the fourth operation. But as per our convention, if we do any operation or any transformation with respect to moving frame, so what we supposed to do, we have to actually like post multiply. In the sense, your transformation matrix of I with respect to I minus 1 would be post multiply of each operation. So the first operation, the second operation, third operation, then fourth operation. In the sense what one can see, the Ti with respect to I minus 1 would be rotation about xi minus 1 of a alpha I minus angle, then translated along zi minus 1 with the ai minus 1 distance, then rotation along zi with the theta I, and finally the translation along zi di distance, right. So this is the final matrix. You know individual matrix, you multiply. So for benefit of viewers, so I have seen that I have consolidated this. The first one is transformation, you can say rotation about xi minus 1, then the transformation which is translation along xp, then we have done the rotation about zr, then finally translated along zi. So these are the 4 matrix, right. So you post multiply, that is what we did. You can see this is the post multiplication. So this is the individual matrices, right. So finally you will end up with the matrix which is what you call transformation matrix. Now you look at this transformation matrix, how many parameters are there? Only 4, right. So ai minus 1, so alpha I minus 1, di and theta I. These are the 4 parameter. In the sense, the transformation matrix of I with respect to I minus 1 is function of alpha I minus 1, so ai minus 1, so theta I and di. I am writing in the order also. Okay, first we did, second, third, fourth. So now this is what we call arm matrix. So now finding this arm matrix, there are several way. Okay. So one we call standard. So standard in the sense what we see. So you have actually like, you can say link I minus 1, that would be having, you can say link I minus 1 would be having, you can say axis would be I minus 2 to I minus 1, that way we can take. This is what we take in the other way around, this is I and this is I minus 1. So what we are actually like trying to realize in the standard form, you take this point, okay, and this you take how this link progress, okay, how this link progress and how this link is actually like coming. So now this is coming like this and this is progressing this. So this angle you can call theta I and this distance you call di, okay. Further what we are actually like seeing that the zi to zi minus 1, what angle after this, in the sense you are looking at link I. So what angle twisted and what angle, sorry, what distance is actually like traveled along the x. So if you are using that way, first you have rotated this one, then you have translated, then you have rotated and then translated. In the sense you will get a different way, but one benefit is actually like this is actually like giving the information of next joint, that is what this alpha and a. But benefit what here is, so everything would be ai, alpha I, di and theta I. But what we did in the previous, this is mixed of I minus 1 and I. So that is why we call this as non-standard form. but this is actually like very much beneficial when you think about understanding. So you can see like here, so we take I minus 1 and I, but if you look at the previous one, although you call I minus 1 link, but the axis you will denote 1 before. So this is always confused. So when you think about actuator, you want to control the actuator 1, but on this paper you have to control the actuator of 0, okay, because you are actually like using the axis 1 down. So you can see like our convention, if the link I minus 1 would be having two joints, which is I minus 1 and I, but if you take a standard form, so that would be I minus 2 and I minus 1, that is the basic difference. So but we are actually like all the time we are actually like favoring the non-standard form, because that will give more intuition, and whenever you are getting tau, which is actually like torque for certain motor, or the force of certain linear motor, or the angular displacement of any motor, that would be directly denoted to the axis which you are referred to, but the standard is not that way. So now you can see this is the non-standard and the previous one is standard. So these are the two matrices will come. So you can actually like see very similar. So this is actually like the joint information is clear, but the link information is actually like AI, and alpha I is actually like proceeding joint, okay. The link parameter is actually relative information of two joints, right. So that would be in this case the proceeding link, but in this case the current joint to the proceeding link, and the joint angle also would be that way, okay. The link to link and joint to joint, which is exact correspondence. So that is why we use the non-standard, but some of the textbooks which you are going to refer may be giving the standard form. So one should know. So this is what we have actually given, okay. So the other way around, people used to say, so the non-standard is something like you are starting from the base to the end, okay. The other way around is actually like you are standing in one particular joint. So you see the joint parameter with respect to previous, and you see the link parameter with respect to you and what is proceeding. So in the sense you would be standing here and you will call the information before and you will give the information to the front, but the non-standard one is slightly different. You will travel along the path. So that is why I favor this non-standard one. So I will just end up with this two further slide. So what is that? One is actually like the advantage of having non-standard is the rotation of theta I always around the Zi. So in the sense you denote Zi as 1 and the theta 1 is corresponding to that. In the sense your actuator would be belongs to that. The joint number and the coordinate number coincide, okay. And because of that your actuation force is directly the same place, not like previous one. So this is one of the main benefit, that is why we are using non-standard. In addition to that, what happened, the link geometrical characteristics always actually like beneficial, because this would be directly can be denote the center of gravity, okay. When you have your body and this is the joint and this is the centroid and this is another joint, you can always denote this with respect to this frame or this frame, okay. But if you use the standard, you have to actually like recall all the time before, okay. And the disadvantage always there. So the disadvantage is actually like mixed of the indices, okay. What indices? So I minus 1 and I would be inside the arm matrix, where alpha I minus 1 and AI minus 1 would be exist, theta I and di would be other set. So this is the disadvantage, but it is actually like not going to create much confusion once you are getting familiar. But as I already said, applying which method you want to do, it is a purely personal preference. I am preferring this, and my course entire thing is going to follow the non-standard one, but some of the textbook would be talk about the standard one, okay. That is what the one of the easiest thing. As I already mentioned, this lecture we are going to use the non-standard representation. So now we will talk about general in the sense what is the benefit of DH we have seen, but what are the shortcoming. So the shortcoming already we have discussed in the beginning itself. Every link should be having considered as a binary link. In that case, if you use a ternary link or quaternary link, it is not straightforward. Second thing is every joint should be 1D of system, but if you have a spherical joint or universal joint, then you have to consider as virtual mass or virtual body, and then you have to get it. In the sense, you have to actually like what you call, you have to decompose those joints into number of, you can say 1D of joints. So that is the thing. And third thing is actually like if you have a, you can say parallel axis, so the common normal can come at infinite location. So how will you find that, right? So this is actually like another case. It gives some benefit and the same time it give a trivial, non-trivial solution also. So that is what the idea here. So in that sense, you can actually like see these are the cases. So now you know like what is DH representation, how we obtain the arm matrix, and now you know what is the shortcoming of DH parameter or DH method, and what is the basic difference between the standard and non-standard. The next lecture we will see some of the example, we will see some of the physical robot, and we will configure into a line diagram. Then that line diagram we will actually like mark it as a frames, and then we will find it whether this Danavitt-Artenberg representation is useful or not. Okay. So with that I am ending this particular lecture. See you then, bye, take care.